These are the solutions to Chapter 3 Standards Assessment, and this is our preview or pre-test before our benchmark. And so this is the last section we're going to be looking at before our benchmark, and so let's take a look at the problems. It says the border of a Canadian $1 coin is shaped like an 11-sided regular polygon. The shape was chosen to help the visually impaired people identify the coin. How many degrees are in each angle along the border? Round the answer to the nearest degree. Well, first thing I need to do is find out how many degrees, the number of degrees in or for the sum of those degrees in the 11 gone, so the 11-sided figure. And so what I'm going to do is I'm going to use this formula, n minus 2 times by 180 degrees. N stands for the number of sides. And so what this gives me is the sum of the interior angles. And so once I have that sum of the interior angles, then I can do another operation to find out the degrees of each angle. So what I'll do is I'll put the 11 in for n, and then minus 2 times by 180. So that gives me 9 times 180. And so I'll go ahead and do 9 times 180, and that gives me 1,620 degrees. So that's in the sum of all the interior angles. Now I just want one. So one angle, and I know it's all the angles are the same because it says that it's a regular. Regular means every angle is, or every side is exactly the same. So I just take that 1620 and divide it by 11. So we'll go ahead and do that. Divide by 11, and that gives me this number, 147.27. 147.27. It looks like the 27 repeated. And so it wants us to round to the nearest degree. So that would round to 147 degrees. So that would be our answer. So looking at the next one, it says a public utility charges its residential customers for natural gas based on the number of therms used each month. And the formula below shows the monthly cost C in dollars and is related to the number T in therms used. And so it says the formula right here, and they're just asking us to solve for T. So the first step I'm going to do is I'm going to move that 11 over. So you're just undoing the equation to isolate the variable T. And so I'm going to subtract the 11. Now you can't take 11 from C, so I just have to write that separately. So I'll just do that, and then I'll divide by 1 6/10. 1 6/10 on all sides. And so this is what I've got now. I've got C divided by 1.6 and then minus 11 over 1.6. Now that's what I've got so far, and let's take a look at the different choices they have. Well, I don't see that exact choice, but this one does match right here. You see, what they did is they just didn't divide it separately. They just divided it as 1. So it would have been this section right here, C minus 11 over 1.6 equals T. So I could have extended that fraction bar. And so either one of these would be right. Since it's multiple choice, this is the one we'll take. So I'll distribute that 5 over the x minus 4, leaving me with 5x minus 20. And then this all equals 3x. So I want to subtract that 5x from all sides. And that's going to leave me with negative 2x equals negative 20. So I divide by negative 2, and that leaves me with x equals 10. It's not 110, but just 10. So x is 10. So let's go ahead and find that answer there, and it looks like it is I. Moving on to the next problem, and it gives us this figure. It says the figures below show triangle PQR, and it's real important whenever they're giving us the letters that correspond to the different sides here. That means that like P corresponds to S. Those two correspond together. So let me get rid of some of those little markings here so I can show that a little bit clearer. So I'll use color to do that. So the P here corresponds to the S, and then the O corresponds to the T, and one other color here, we've got R, and that corresponds to U. So that's real important as we're looking at this, and it says that it's a dilation. So what that tells us is that if it's a dilation, that means the figures, the triangles, are similar. And if they're similar, that means we need to use proportions to solve. That means the sides are proportions, or proportional. So let's go ahead, and they want us to find out, says what is the value of x. Okay, so this side right here. So I'm going to take, what I like to do is I like to take the two sides on one triangle and write those as a fraction. Now it's real important to make sure we get the side that corresponds to x. So x is QR. So this is QR here. And so I need to make sure I find the side that corresponds to that. So Q, actually that looks like an O. Well, I guess this was a Q right here. QR. So QR are the last two. It's the pink and the green. So the pink and the green are TU. So that means this needs to be T and U. So TU is right down here, 18. So those are the two sides that correspond. Now we got to find 12. 12 is QP. So QP is the blue and the pink. So blue and pink is S and T. So S and T was represented by 16. And now I've got the proportions set up right. So there's other ways to set it up. As long as x and 16 are diagonal from one another, you're going to get the right answer. So I'll go ahead and cross multiply. 16x equals 12 times 18. And so I can go ahead and multiply out those numbers. So we'll clear this one. 12 times by 18, and that equals 216. So 216 equals 16x, and we divide by the 16, and we'll see that that would give us 13.5. So 13.5 is the value of x. So let's find that one right here. There it is. So here it says, what is the value of x? Well, when I look at it, I see parallel lines. So this and this symbol right here tells us that we have parallel lines. And so if those are if the lines are parallel, that means that the obtuse angles are going to all be congruent, and the acute angles are all going to end up being congruent to one another. So if I look at this, I see 125 here, and that means that this would be 125, this one's 125, and this one's 125. And I can prove it by using some terminology like the 125 is vertical to this 125. This 125 is corresponding to this 125. This 125 is alternate exterior angles. And so that's how I can prove that. Now, x is not a 125. It is an acute angle. So what I need to do is I need to subtract that 125 from 180. So when I do that, I borrow a little bit, and I end up with 55 degrees. So that tells me that all of these little angles here, these acute angles, are all 55 degrees, including this x. So x equals 55 degrees. And so one way to prove that is I could say that 125 is corresponding to this one here, and then supplementary to the x value. So let's move on to the next one. It says that Olga was solving an equation in the box shown, and we got to find out what her error was and correct that error she made. So when I look at it, it looks to me as though she did not distribute the 2/5 over the 10 and the 15. What she did is she multiplied by -5/2. And so in order to get rid of those 5s and the 2's, but there's the mistake right there. See, she didn't do that. She multiplied by 2/5, and that does not cancel out the 2/5 here. It actually makes it 4/25, because you'd multiply straight across. 2 times 2, 5 times 5. So that was her error. Right away we found that. So she should have multiplied both sides by -5/2 instead of -2/5, and that would have given us the correct answer there. So F. So she should have changed this to a 5/2, and that should still be negative, but that's where her error was. So moving on to the next one, it says that in the coordinate plane below, triangle XYZ is plotted and the vertices are labeled. And it says, which of the following shows XYZ with primes and the image x, y, z after it has been reflected across the y-axis. So across the y-axis is going to go onto this side right over here. So notice how this point right here is going to go 2 spaces over. And it's going to go right there. But watch what happens. The x value changes. The y value is staying the same. So whenever you reflect something across a y-axis, that means that, again, it's just the y value staying the same, x value switches sign. So that's what we need to look for. So when I look at that, I find the one that matches that point. It's right here, 2, -3. See that one? They went straight across. They were in the third quadrant, and then they moved to the fourth quadrant. And that's what they did with all these points. Notice the -3 to -5. That point ends up going over here about, and that one ends up being 3, -5. And then this point over here, it goes way over here, and it becomes 6, -1. And that's what we have right here, 6, -1, 2, -3, 3, -5. And so that is the answer. Let's take a look at the last problem here. And here it says the sum S of interior angles measures a polygon with n sides can be found by using a formula. Write the formula. Well, we wrote that in the first problem. N minus 2 times by 180 degrees, where n equals the number of sides. And so it says a quadrilateral has angles measuring 100, 90, and 90. Find the measure of the fourth angle. And so this is a quadrilateral this time. Quadrilateral means 4 sides. So quad means 4 sides, and so we know that a quadrilateral, 4 minus 2 times by 180. 2 times by 180 makes 360. That's why a quadrilateral has 360 degrees for the sum of all the angles. So what we need to do is we want to find that missing angle. So it's x, we don't know what it is, plus the 100, plus the 90, plus the other 90, and that all equals 360 degrees. So I add these numbers together, I get x plus, this makes 180, plus 100 is 280, equals 360 degrees. So I subtract that 280 from all sides, and I do a little borrowing, and I get 80 degrees. So x is 80 degrees. So that was part B. And part C, it says the sum of the measures of the angles of a pentagon. Pentagon is 5 sides. And it says that pentagon shown is 540 degrees. So that's the sum of all the measures of the interior angles. Divide the pentagon into triangles to show why this must be true. So if I go ahead and do it this way, there's one triangle. So this triangle has 180 degrees as the measure of all the angles inside. And then I go ahead and cut this trapezoid into 2 pieces. And so this one has 180 degrees, and this one also has 180 degrees. So that is what you'll end up seeing, or types of problems you'll end up seeing on the test tomorrow. Good luck.